Hey everybody. So this is welcome to week 3. What is this? Day 4 office hours.
Yep.
So we don't have any new content today. If you were watching the announcements channel, there was no new announcements today. So we're really just going to be going over, composability, I guess, maybe have some discussion around composability, flow in general, any questions you may have about any of the content from the previous weeks. It could really be anything. This is more just to serve as an open-ended discussion around composability. We've also received a bunch of messages in the composability discussion channel, which have been super cool to see that people are searching through the Flow ecosystem and finding some cool stuff out there. And I have loved seeing people discuss with each other. So that's been great. Thank you to BZ and HH, the Spark especially. But yeah, besides that, this is really just going to be an open-ended discussion around composability. It looks like we only have BZ here. So thank you, BZ, for coming once again. Maybe we'll play some Flappy Bird for you, beat 27. But yeah, besides that, unless BZ, you have any specific questions about composability, we could just, I don't know, start talking about whatever. What we could do if we we're going to composability. All right, sweet. Yeah. So if it could be about anything. If you have any questions, feel free to ask. If we don't have any direct questions, what I would love to do maybe is to go through the composability discussion channel and we can walk through some of the things that were said and maybe expand on them. That would be cool.
Yeah, I think that's a good idea.
All right. Let me share my screen. So here we are. So I opened this discussion channel on composability, and it looks like we had some comments from HH Spark, Ned, and BZ, which was super cool. So let's see. So let's walk through this and maybe expand on these together. So HH Spark was saying, "Hi, I'm new to the Flow ecosystem. Do they have DeFi products like stable coins and DEX?" So from what I know, I mean, Nick might also would answer this well, but from what I know, they actually have FUSD, which is the Flow stablecoin, and BC actually answered that down here, which is pretty cool. And this was actually a new thing they're doing. This didn't really exist until maybe 2 months ago, or maybe even a month ago. So that's just a new thing they've been exploring. The other thing they had was like, as you've seen, we're working a lot with Flow token. That's like the native currency on Flow. So those are the two that I'm aware of that, exist in the Flow ecosystem. He also said, I'm interested in DAO related contracts as well. Whatever Ethereum has viable products, as a builder, I would like to see whether we can have a chance to build on Flow or Solana or others. Yep.
Yeah. So when we start sort of officially promoting the DAO and how all our ducks in a row, it's going to be for multiple chains. It's not going to be only Flow. What we didn't want to do is experiment with all of them in parallel and screw them up all in parallel. We wanted to learn, as we go, with one, kind of iron out most of the wrinkles, and then meanwhile have the engineering work done. But a lot of the success of this DAO and this model it's really not technical. I don't believe it's really about process and policy and governance. So we want to have those kind of things fairly well defined. Like there's no way to do it perfectly, I know that, but if we can get 70 to 80% done, then we can tweak it as we go. But our goal is definitely to do it with the others. And I'm fairly certain at this point that we will target the EVMs next after Flow, just because at one stroke, we can capture multiple blockchains, including level 2s. So yeah.
Yep. BC was also saying building some lending/borrowing protocol on Flow would be pretty cool, or some bridging protocol so you could turn your BEP20 or ERC20 tokens into an equivalent fungible token on Flow. Binance has this neat video regarding how they have been doing the bridging between networks and how that's maybe possible. Obviously, making both and combining them into the same ecosystem is ideal. I would definitely use it myself to borrow for buying a house and just use my tokens as collateral. Yep, instead of going to the bank for a loan, making it easier is more. Making it is easier said than done. Yeah, I totally agree.
Yeah, I know at least one, maybe two projects that are working on on the ability for you to collateralize things like your NFTs or your token, your fungible tokens. Also, I'm not at liberty to say what they are right now, but bridging right now might be like a slightly toxic subject given the $600 million shenanigans happening on the Poly network. But I'm, that'll pass. It's blockchain. Next week it'll have passed. But yeah, so the thing is, the ability to build something like that and bring it to market, it's a little complicated, and I think it requires a team, and it requires a focused effort, and probably requires a little bit of capital also to get going. But of course, in the hands of a determined developer, anything is possible. I always keep open that, that possibility. But I think those kind of things are going to require a team to come together and be very focused at it because of the level of complexity and sophistication involved in that. Not so much in implementation, but in ensuring that it's secure, because that, like, you got to really look at so many different angles, because if there's money flowing through it, especially at scale, it's going to be a target, and you have to be really careful. So yeah, if anyone is going to work on that, we would love to have that kind of module on the registry, and we would certainly support by providing engineering resource support as much as possible.
Yeah, and the thing about this too is, like, thinking about this $600 million hack, obviously it's a sensitive subject, but this is why things like Flow are, so awesome. Is, as we've been exploring the past couple of weeks, the security on Flow, which is, one of the main points of concern for the Flow team when they were building this up from, the ground up, is, how secure the Cadence programming language is. And so I think Cadence itself is so much more suited for things like this, but we just haven't seen that in a large scale sense yet. So just progress saying, perfect. Ethereum has viable protocols and working products in production. This is no brainer for me to build the same effect, but with resource-oriented composability architecture. If you check the Ethereum adoption, you will find out they enable innovative applications: token sale, token wallet, and banking, token swap with AMM, token auction, loan, and stablecoin. In my opinion, for any layer one blockchain, the community needs to have this vision to build product-ready financial apps. Look at Hyperledger, a great open source project, beautiful architecture, even have their composer language. What are they missing compared with Ethereum? Ethereum is smart to pick this domain of use cases and 100% commit on token economics. This is how they create disruption and impact. For the Flow community, we need to catch up above use cases and identify gaps in experiments quickly. This will be a great market/product forcing function to drive our exploration for composability between utility-oriented versus domain-specific. Yeah, so what I think this is getting is that, like, a lot of these things like token sale and auction and loan and stablecoin and stuff like that are, already, like, not maybe fully solved or anything like that, but are, out there in the Ethereum world. But we haven't seen a lot of stuff like this yet on Flow. I think, what's been so interesting for me is, ever since I started building on Flow a little bit before the OWB bootcamp that Flow had last year during the summer of 2020, I think that, like, Flow in general, like their marketing strategy or whatever it is, or their main focus is on creators. And so it's been really interesting to see all the projects that have come out of Flow, especially in its early stages, whether it be NBA Top Shot, MotoGP, a ton of NFT marketplaces. That's just been huge. So there's definitely been a focus on creators and NFTs in that sense. And stuff like this has kind of been pushed to the back a little bit. But it would be cool to see this transition on Flow. BZ was saying ETH ecosystem has all these applications you mentioned because of first mover advantage and network effects. If Flow community would want to catch up, it would be more likely to do so not by just copying the applications made on ETH ecosystem, but by mostly building useful applications that aren't as easy to build / execute on ETH due to scalability issues and developer expertise barrier / composability issues IMO. Yeah, so I like just reading this over again. I agree with you, BZ, because it wouldn't be smart for Flow to they built up this whole thing around security, developer usability, developer readability, all these new things that ETH was lacking. I think you don't just go out there and make a whole new blockchain unless you see problems with something else. And I think that's what the Flow team really did was they saw some problems with ETH, the $6 million hack that happened a couple days ago. So yeah, it wouldn't be smart for the Flow team or for even the community around Flow to just go out there and start copying Ethereum projects or implementations or whatever it may be, or Ethereum architecture. It would definitely, if the Flow community wanted to catch up, like you're saying, then yes, it would make sense for people to take the mistakes that they saw in Ethereum and how Flow solves that and build it up again. But similar to what you and both HH Spark are saying, we definitely do see like a lack of this kind of stuff on Flow. And I think that's just because NFTs in general have been so big and have taken up a lot of attention of the community. And especially because whether or not, even if the Flow team, was trying to focus on stuff like this, which they are, they did FUSD and, they're focusing on stuff that's not just NFTs. It is really clear that you need the community to also be thinking in your, same mindset. If the entire community around you, especially on Flow right now, is so focused on NFTs and NFT marketplaces and stuff like that, then it's hard to push these things across and to generate excitement about this kind of stuff.
Yeah, just about every project I talk to is NFT related in some form or some shape or form. And I do think that whatever we do in the Flow ecosystem, it shouldn't just be copying what's been done in Ethereum. I've seen level 2 chains doing just that, and it's not innovative at all, right? We want to do something interesting and innovative, etc., and build upon that. So yeah, I think one of the things we want to do post this boot camp is to create this sort of a community council or group of members such as yourself and anyone else who wants to participate and think a little strategically about innovation and figure out, okay, what are some cool things we can build? And what we want to do is we want to support developers building that and collaborate on those kind of things, so we can bring some new innovative things that are yes, certainly NFT, because that's like the sweet spot for Flow, but also can we do things in other areas like DeFi, or as I posted in earlier, I really think there's opportunities for hybrid DeFi NFT kind of applications. So whatever we do, like, we're excited about collaborating and innovating. Innovation is something that really excites me, and I'd love to come up with new ideas.
Yeah. And this was interesting. So HH Spark said, if you're interested in NFT competition, there's a good ranking data at cryptoslam.io. I actually haven't taken a look at this. Let's see here. It looks like NBA Top Shot is, I haven't even heard of Axie.
So Axie Infinity is the biggest game right now going in the Philippines. This is the one we discussed at our team stand-ups at Decentology. So essentially, it has given people in the Philippines the ability to earn a living during the pandemic, even people who are out of jobs, etc., by essentially playing a game and, creating characters and selling those characters, etc., and making a lot of money. So in the Philippines right now, it is insane. I mean, that's the largest group of users. I'm not saying it's limited to the Philippines, but it's growing pretty rapidly worldwide.
Wow.
Yeah, and you can see that for NBA Top Shot, it's sort of been a lull in the season, because what happened is that it was on fire earlier this year, all the way through April, even, and then they were just too big and couldn't keep up with the demand, etc. So they put in a lot of checks and balances and things that slowed things down, and they focused on addressing a lot of the problems people were having. Like, for example, people couldn't withdraw and do those kind of things, and so they a lot of people were disgruntled, and so they took a step back and focused on that. But if you've seen the past couple of weeks, they are back in a big way, especially doing live events. Like, just is it tonight or last night, they finished their 3-day stint, I think, in Vegas, where you could during the game you could buy a pack and mint, like, for a live game moment, and mint it. It's minted and all that, and then you can open the pack, etc. Right away. So there's all these tweets about people doing that, etc. So there's a lot of excitement coming. And honestly, what we've seen so far in NBA Top Shot, given that there's how many million fans around the world, like I think like 100 million or something like that, it's going to explode. It's going to grow much, much more. So I'm very optimistic about that.
Yeah, NBA Top Shot was such a crazy time when
Yeah.
It was actually really interesting, because I don't even think the Flow team themselves expected it to blow up that much. I remember being like one of the first couple hundred or maybe a couple of thousand users on the platform, and it was so weird how, like, at first there were so many packs available, and like you could go on there anytime you wanted and just buy a pack, and then it seemed like it took a few weeks, but it seemed like in 1 week or so, it just blew up so much that when you joined like a wait list for the pack lines, your whole computer would like start crashing, because it was like so buggy, and it was so difficult to, there were like just hundreds of thousands of people in line, and it was, I think even for the Flow team, it was such a shock, right, Nick? Like
Oh yeah, they had to staff up very, very rapidly. And staffing up is not easy. You can't just hire random people. You have to interview them, you have to check them out, you have to make sure they're a good fit and all that kind of stuff. But they're getting there. They've hired some really key strategic positions, and you can already see from like some of the improvements in speed of the funds transfers and all that kind of stuff, that it's improving significantly. A lot of people in the community are accusing them of really being too generous and having too many releases and things like that. But that's kind of a situation where you're damned if you do, damned if you don't. If you don't do enough, people are like, hey, what's going on? It's not enough. It's just catering to the whales. But if you do too much, then they go like, it's too much. So I think all we can do is just wait and watch and see what's going on, and trust that the people who have created two of blockchain's biggest experiences know what they're doing. I trust in their experience.
Yeah, that's so true. I remember that when there were not that many, there was like a pack sale like once every week or something, and everyone was like, more packs, and then they would do like a few pack drops a week, and they were like, you're overloading the ecosystem, and it's just it's so hard to get it right, especially when you're innovating, and it was just so cool to be a part of that. So we actually have a question here that I never got around to. Why on this line of code? I guess this is helpful for everyone. So why on this line of code, self.receiver, we're getting a count, we're getting a capability here, and we're borrowing a reference to some sort of non-fungible token collection that's being exposed to the public. The type reference in borrow is non-fungible token, not collection public, and not, for example, Kitty. Oh, it's a great question. I got lost in a capability of Kitty items, but then borrowing with a non-fungible token contract. Yeah, that's actually a fantastic question. The truth is, you're asking why. The truth is, there's no real reason. It's the same exact thing. The truth is, like, in order to seriously answer this question, I would have to see what we're doing with the receiver resource here, or reference. But I'm assuming that we're just getting like IDs or something, because kitty items collection public is the exact same thing as non-fungible token collection public, but with one extra function called borrow NFT, I believe, or it's called borrow entire NFT. So you can really use either one. You really have to think about what the point of this local variable is. If the point of this local variable is just to expose the IDs in a collection, which I'm almost positive this is what this is doing. If not, you can correct me, but I believe that this is just exposing the IDs, and both the non-fungible token collection public and kitty items collection public expose the get IDs function. So it's the same thing. This is a great question, and I don't think the participant who asked this question is in the Discord. So I'm also going to answer this in text, but it's a great question for everyone to look at. Also, if we don't have any questions, and since we've already gotten through the composability discussion channel, I would love to pull up maybe a more complex or difficult example of composability using the subscription module that we were doing a while ago, Nick.
Yeah, sure.
And that also has like charge NFT stuff in it. So do you think that maybe we could go over that, like how you would incorporate finance and stuff like that?
Yeah, let's do that.
All right, let me actually load up a project right now.
We have Sanket joining us. Hi, Sanket.
All right, so I'm not gonna lie, it has been a second since I've looked at this, but I think this will be fun to go over. So in the past few days, we've been working with registry contracts and stuff like that. And the one example we were using was the registry NFT contract. Now, inside that contract, we just had a total supply and an NFT minter. And if we, just as a review, the reason we had those there was because in our tenant resource inside our, registry NFT contract, I'll actually pull it up right here. And I'll go over these in a second. But in our tenant resource, we have two things. We have contract level definitions. So these are variables that are defined at the topmost level of the contract. And we also have stuff that gets saved to account storage in the contracts init function. So in the example we were working with the past few days, our tenant resource had maybe a total supply in it, and it also had a minter resource. And you can see here that I actually have the public set total supply here. So this is like slightly outdated to what we were learning this week, where I actually told you how to encounter this sort of problem. But in this office hours, I want to go through a more complicated example where we don't just have an NFT contract with like a total supply and a minter, but we have stuff like this subscription contract. And this is a registry contract that deals with like subscriptions. So if you as the caller or the user wanted to have subscriptions in your dApp, then I apologize if you can hear my dog, by the way. My dog's going nuts. But so like if you have a registry contract that deals with subscriptions, and if you have a dApp that is a marketplace, or maybe is some sort of NFT, or maybe you want to make it so that you can only give a user an NFT if your subscription contract says that a user is subscribed, something random. But the idea is that we have like some sort of subscription contract here. And there's a ton of other stuff in this tenant resource that we didn't have in our NFT contract. And so we can walk through this together and go over like maybe how we'll deal with some more complicated data. So I don't want to walk through this whole contract because it'll take some time. But essentially all it's doing is handling subscriptions for a user. And so let's walk through this together to see what data we may store, what capabilities we may store, as you see here, stuff like this. And this is actually, I'm glad we're going over this now, because this is a great example of some other things you may run into along the way. And we actually, I just realized now that in this bootcamp, we haven't really talked about storing references inside a resource. So this is perfect to go over. Okay. So we have a few things here in our tenant resource. We have one thing called a subscription types. And what this is this just maps like the name of a subscription. So I don't know, we can call the subscription whatever we want. And that just maps to a subscription type struct. Now, again, it's I don't want to spend too much time on this to bore everybody, but essentially this is just a dictionary, right? And so we're storing this inside our tenant resource, and it's publicly settable because we change it at some other parts of our contract. And so this is very similar to the total supply, where actually let's search for subscription types, and let's see where we're modifying it in the contract and see why it's publicly settable. So right here, actually, you'll see that in our administrator resource, because we want our admin to add us a new subscription type, let's say some random admin that has this resource wants to just add a new subscription that allows you to subscribe to a newsletter, and they're calling the newsletter subscription or something like that. Then when they add the subscription type, they're going to have to pass in, or they're going to have to get access to a reference to a tenant, and then they're going to change the subscription types, maybe add a key and value pair to that dictionary. So this is why the subscription types has to be publicly settable. So this isn't too interesting, because we've already looked at some examples where we just have a simple publicly settable dictionary, UN64 or whatever it may be, and we're changing it outside this resource. But this is going to be pretty interesting to go over. So we haven't talked about this a lot in this bootcamp, but along the way you might encounter like problems with trying to store a reference inside of a resource. So this tenant resource, as we know, gets stored into account storage, right? When a tenant comes to this contract and wants to get its own resource, it's going to call the instance function. It's going to receive a tenant resource in return and store it in account storage, right? As we've seen. And in order to change the data on that tenant, you need to borrow a reference to that resource, and then you can, pass into function calls, whatever it may be. But there's this concept in Cadence called storable. And what that means is a resource that gets stored into account storage, and it's only storable if it fits a certain amount of requirements. Now, the requirements, there's a few of them, and actually, you know what I'll do? Actually, I'll just share my whole desktop, and let's actually look this up together. So let's actually go to the OnFlow documentation page and walk through storable together, because I think it'll be helpful to also show you where you can maybe read about this on your own. So here we go. So let's go to the storable section. So, okay. So it says that field types must be storable. So if you're storing a resource inside your account storage, it has to be storable, right? And it says non-storable types are, so if it's any of these things, this means that we simply can't store it in account storage. So functions, accounts, transactions, and references. So these three seem kind of obvious, right? Like we're not really going to be storing functions inside of our account storage, but this one seems to trick people up a lot, the references one. And what this means is that if you have a resource, so in our case, the tenant resource, we can't store a reference inside this resource, or else it won't be storable. And if it's not storable, we can't actually store the tenant resource inside our account storage. So the workaround for this is to instead store a capability to a reference. And if you do this, then, if we go, let's go to our init function, you'll see that I'm actually storing, I'm initializing flow token vault to nil. So what this is doing is, let's say, I want to make my own subscription, and every time someone subscribes to that, I get 10 flow token, right? Well, we need to actually give the contract a vault to deposit that flow token into, so that we can earn money ourselves. And right now, this just exists within the tenant. But as I work on this project more, the goal is so that this flow token vault maybe applies to some administrator or something. But for now, we have one flow token vault that is receiving payment when someone subscribes to our contract. And so if you, actually one of the things I was doing initially was just doing this, right? Where you're storing a reference to a flow token vault, but you can't do this. It'll say tenant is not storable. So the workaround is to actually pass in a capability that's a type optional. So you can initially set it to nil. And then inside our, add flow token vault function is where we're going to pass in that capability and set it right here. So I'm realizing now that in the kitty items example that we were working with during week 2, you actually saw an example where we were storing an owner token vault and an owner kitty items collection inside our marketplace contract in that sale collection resource, if you remember all the way from back then. And if you remember, we were storing 2 capabilities, and that's exactly the reason why we were doing that, is because you can't store a reference inside a storable resource. You have to store a capability instead. And let's actually see how we're passing that in, because this might be helpful as well. And I'll actually go over another problem that we may encounter. So here we go, add flow token vault. So what we're doing is, this is when we're actually calling that function called add flow token vault right here to add that vault to our tenant. So the tenant is the one running this transaction. And you'll see that we borrow a reference to that tenant here. And then this is something that you probably haven't seen, but we're doing a count.get capability, and we're not borrowing or anything, right? You see there's no borrowing here. We're simply just getting the capability. And what this is typed to is a capability that, is a reference to a flow token vault with fungible token receiver restriction on it. And we're passing that in. Now, one thing I actually want to talk about that I've discovered over time is that sometimes, like in this case, we're only able to get a capability because of the fact that it's been previously linked to the public. So this is done actually automatically on the Flow emulator because the Flow team has implemented it themselves. But let's say, for example, that you have your own fungible token that you're not automatically exposing to the public. You actually can't get this capability. You'd have to personally link it to the public. Now, there's one problem that you may encounter where, let's say you don't want to link your collection to the public, right? Why? Like, let's say I have my own fungible token vault and I don't want to expose that to the public. So I am the only one that wants to be able to use it. Well, then how do we go about this scenario? Because we have to, get a capability to that vault here. We can't just pass in a reference. So the solution to that is to actually use private capabilities. So instead of, let's try and find an example where we're linking NFT, maybe provision account. Yes. So you'll see right here that we're account.linking a new NFT collection to the public over here by doing public/NFT collection. Well, you can actually specify a private path called private. And what this does is make it so that only us, so only we can actually look at this capability. So it's basically a way of saying, well, I want a capability, but only for myself, which seems a little weird at first because capabilities are supposed to be, for the public, and for what we've been doing so far, it's always been for public consumption. But that's definitely not always the case. And sometimes you'll want to expose a private capability. And this can also be very useful in cases where, let's say I want only a certain number of people to have a reference to my collection, let's say. Well, what I can do is, instead of exposing it to the public because everyone would have access to it, I can instead expose it to the private field and then pass that private capability to each of the people that I want it to give access to. And then once I have that private capability, they can .borrow and use it and all that stuff. So that actually, I just went on a whole tangent that had nothing to do with composability about private capabilities and storable. But yeah, that just went completely sidetracked. But are there any questions about that? That's actually something I realized that we might not have covered during the cadence week, and it's just one of those quirks that is helpful to know. It definitely applies also, by the way, to our tenant resource. So I guess it's not that off topic. I see Solver's asking a question, so I'll wait for that. And after this, I'm gonna dive a little bit into the registry service that we've been building up to deal with payments and stuff like that. But sorry, no, don't worry, it's not a new question at all. So you're asking, does private actually mean our fungible token becomes invisible? So what private means is think about it this way. So let's say you're storing an NFT collection, right, in your account storage. So let's actually go to an example of this right here. We're storing a new NFT collection into account storage. So this is in the storage path, right? Which means that literally only we have access to this. If we don't have an auth account for our account, then this will never be accessible, right? Because it's not exposed to the public. Now, what people usually do and what you've been seeing a lot recently is account.linking, let's say this NFT collection from storage, right? So from storage to the public, which is right here. And what this allows us to do is expose like maybe certain things of the collection we want to go to the public. So in this example, we're exposing our collection, but with these interfaces that are restricting it so that we're not just exposing everything and people won't be able to like withdraw. But the whole deal with private capabilities is that private capabilities are only accessible to us initially. So it's the same exact thing as storage, unless you actually pass that capability to other people. So I'll just write it down here, even though this wouldn't, usually be like where you would write the code. But let's just, for example, say that you account.link and instead of public, it's private. So this now only exists for us, right? So that's like the point. However, if we then do something like, let test capability equals account.get capability, and we were getting a, what is this right here? So I'm just going to copy and paste this type because this is the type that we're getting. And then we had a parentheses, and the parentheses was /private /NFT collection, which we just exposed right here, right? This would be a capability to what we just linked. And we could then pass this private capability to anyone that we wanted to have like specific access to this capability. So you can't do this with storage, right? Because you actually can't get capabilities on storage paths. Capabilities only exist for private and public paths. So if you want this, unique scenario where we only want to give a capability to certain people in, let's say for the storable reasons that we were talking about before, then you would have to use this sort of use case where, you only want to give this to maybe your friends or people that you trust. And so in that case, it would be really helpful to use private. So if third-party app doesn't have this capability, does this mean they can't read my NFT collection? Pretty much, yeah. So like, let's say in this case, right, that we just deleted this line, which exposes it to the public, right? So if we just stored it to storage and then we linked it to private, like without linking it to the public, then yes, only we would have access to it or people that we gave access to. So to answer your question, yeah, a third-party app would not have access to your NFT collection because it wasn't exposed to the public.
One thing I just want to add is all these scoping mechanisms, etc., are important in the context of code execution. But remember, on a public blockchain, all your data is always public. Yep. So that means that someone can read the blockchain directly and get access to what the information is. They can't do anything in terms of transact with it, but they can read it. So don't be under the illusion that private means not visible to the rest of the world. Public blockchains are entirely public. Everything is available for anyone to look at. And that's why if it's intended to be secret, you need to encrypt it off chain and never on chain.
Yeah, I'm so glad you made that point, Nick. I interpreted this question as like read NFT collection in terms of code, but Nick is 100% right that no, this does not mean it's invisible. It's always public on the blockchain. They can read your IDs in your NFT collection because everything is public again. But in terms of the code execution and how we're calling functions in our contract or how we're getting stuff inside our transaction itself, then yes, it's technically inside the code, it would be invisible to everyone else because they just don't have access to it. But yeah, thank you for chiming in. So it's privacy on the blockchain in terms of code like execution, but not, not to the public as a whole. Okay, so other third-party code would not. Yes, yeah, yes. So like they couldn't. Well, again, in terms of like your transactions and stuff, like if a third-party app was calling a transaction to read your NFTs, then no, they couldn't. But the third-party app could go on the blockchain and I'm not even sure how that's done. Do they just query like? Can you just query data off the blockchain, Nick? Is that like a thing?
Sorry, trying to hit the unmute button and missed. Absolutely, there are tools to do that, and in fact, uh, companies like the Graph, etc., are modeling themselves as sort of the Google for blockchain, because the massive amount of data that's there, it has to be indexed and readily available. So Graph is creating a search engine for the blockchain, and I'm sure it'll arrive for Flow also at some point. But essentially, it's just enumerating every block, enumerating every transaction without the block, and making it visible. It's all there in more or less binary form. So that's why it's not human readable right away. So, but that's very easy to decode and make human readable. Things like logs. Logs are really, in particular, very valuable to harvest from the blockchain, because they give you a vector to figure out what has happened in an application. And then you can backtrack from there and say, someone transferred something to someone and it was for X dollars or whatever. So you can then use that knowledge to go trace those two accounts that were involved in the transaction and see the history of it, etc. And if you look at NBA Top Shot in particular, at the number of projects that have cropped up that do that for NBA Top Shot, it's pretty phenomenal. Like there's the Moment Ranks, and then there is I'm trying to think. There's a bunch of them. In fact, I think NBA Top Shot community in their Discord has a page where all those are there. There's at least 5 projects I can think of, but I think Moment Ranks is one of the top ones, where they're basically just reading the blockchain and figuring out what's going on, and based on that, creating an alternate user experience for NBA Top Shot, where, for example, as people are adding listings to the marketplace, it's telling you if it's hot or not. It's showing you like a flame or an ice indicator on whether it's a good deal or a bad deal by analyzing things, etc. So that's basically the type of thing you can do with blockchain. Is someone with an arbitrary, can write an arbitrary application that looks at your application data and perhaps create something that's more value added. And that's the beauty of blockchain, is your smart contract is one, but anyone can create a client application for it, including mobile applications.
Yeah, honestly, this is a question for me. I was actually having a conversation with I think it was HH the Spark earlier this week about accessing like data on the Flow blockchain. We had brought up FlowScan because FlowScan allows you to see like transactions and scripts that are being executed on the Flow blockchain, etc. But FlowScan, as from what I understand, is like a community. Is a project that was developed by the community lead in the Flow Discord. But I wanted to ask you, like, are there any applications out there that allow you to like read directly into maybe your collection that's maybe in your account storage or something like that? Or if not, like, how would one go about doing that? Like, what tools are out there to help you?
I had actually seen a Flow Storage Explorer at one point. I don't know if I find the link, I'll post it. But really, all it takes is for you to sit with FCL or the SDK, perhaps if FCL is not your thing, and just query the blockchain. It's like, if you start looking at it from the perspective of blocks versus your smart contract, resources, capabilities, etc. You just look at blocks and the data in there. You can traverse you can traverse the storage and read it. All the code is there. It's no different than calling FCL to submit a transaction or to read from yours. Like as long as you know the contract address or the account address, you can there are methods in there to enumerate it.
Interesting. So you can actually use the block to just go in there and look at account storage.
Yeah, you can enumerate what are all the transactions and then work your way down. Okay, this transaction involved this account. All right, let me go explore this account storage. So you can do that. And I'm gonna try and see that while you're talking about the next topic here to see if I can find the Floor Explorer thing and post that.
Sweet. So Solver asks, the testnet URL, do you know which of the 4 types of nodes the URL points to? No, but we can try and find that out together.
My guess is that the URL doesn't actually like the URL is an abstraction for handing off the transaction to the appropriate node, because it's like essentially the web front end, right? The nodes are not themselves web enabled. So this would be an abstraction from that. That's my best guess at it, but I could be wrong. So please do explore.
Yeah.
I would like to find that out also. But on other blockchains, that's how it works. There's a little front end RPC server that handles it, and then it figures out what the workflow should be of the transaction.
Let's see. So the Access API is implemented as a gRPC service, a language agnostic specification for this API is defined using protocol buffers. Honestly, this is so over my head, but yeah, I think this might just be over my head for
Yeah, so
you to
it's as I
explore.
said, like so Flow nodes have an RPC front end, then Alchemy has an RPC front end, but generally speaking, all blockchains use RPC, remote procedure calls, as the web interaction thing, because it's simple. It's not as complicated as REST, and it's more sort of suited for real-time kind of data. And there are the multiple types of roles. There's there's 4 roles, or is it 5 roles? There's a validator. There's if you go looking through here, you can see what the different types of nodes are. We discussed this one time, and I don't know if you remember, Jacob. We talked about how there are some nodes that are essentially sealing the block, some that are validating the request, and so on. So there's 4 or 5 types of them, and now we are clearly getting into protocol areas, and we work on the application layer and not on the protocol layer. So this kind of stuff is not natively something that we are familiar with, but but this block header stuff, we are talking about enumerating block. So this is the type of information you can get by querying, the SDK, and you can get all this data for a block, and you can then trace it. So it is a graph, right? So you can follow it along, and in code you can trace it and figure out what transactions were there, and so on and so forth.
Interesting. Yeah, I would definitely have to spend more time on this to be able to answer that well. And honestly, it might be good for me just to learn about this kind of stuff anyway.
Yeah, well, it's an onion. When you go down there,
Yeah,
it's protocol.
I'm too scared.
Layer, and you're going to go down. This is why, generally in the world of blockchain, people are either working at the application layer or the protocol layer, because it's really very different skill set. and it really requires you to understand it. It requires you to be slightly immersive, in that, because it gets really complicated really quickly. And protocol engineers don't care a lot about user experience and, hey, is the user waiting or how are they feeling and all that kind of stuff. They are like more thinking about computers talking to computers, whereas we are at working at the application layer, where we are dealing with, okay, what happens with the user, who does what, whose account has what, and all that kind of stuff. So it's not any different than Web 2. In Web 2.0, you ask your typical DevOps engineer, like, hey, here's some HTML, and they'll be like, I have no idea what that is or what to do with it. Whereas then you have the tools for, setting up, for example, Nginx and configuring it and all of that, and making your web server talk directly with your MongoDB and all that they know.
Yeah.
So it's a highly specialized kind of thing. It's not any different than in the world of medicine, for example. Once you get specialized as a surgeon in the heart or something like that, then you have to go and operate on or do some bone surgery. Yeah, it's going to take you a while to figure that out. You have basic foundational knowledge, but you're not going to be an expert until you immerse yourself in it.
It's so true. Yeah. I've been way too scared to go down that rabbit hole.
Yeah, I'm not scared, but I did that a little bit, but I found that it's counterproductive for me, specifically because there's a finite amount of knowledge you can keep in your head at any time.
Mhm.
And I didn't want to be like super shallow in everything. I wanted to have deep knowledge in at least one area. And so I decided I'm not going to be the protocol thing. Let's leave it to the protocol engineers, and I'm going to get deep knowledge in the stack from the application standpoint and the security standpoint for end users. That's because I can have empathy for what they're doing, etc. With protocol stuff, it really is hardcore engineering. You're dealing with performance metrics, you're dealing with timings, you're dealing with concurrency, race conditions, which is a nightmare of all engineers everywhere. So yeah.
Yeah, to any of you that are still in school, if you ever see the programming language Go, my biggest advice is to run for the hills and never look back.
No, don't say that to people. Go is good protocol engineering in blockchain. So if you're going to be a protocol engineer, then almost everything is written in Go. But yeah, so Jacob, though, but in all honesty, this is surfacing the dichotomy that exists, right? Like, you have immersed yourself very much in the application layer. You work with Cadence, and now you're starting to work with Solidity and JavaScript and things like that. When you start working with languages like Rust, Go, etc., that are really optimized for low level, even embedded stuff, etc., you don't have the familiar constructs that you are used to manipulate.
Yeah.
And so it's like, man, this is hard. This is so easy to do in language X, but here it's so hard.
Yeah.
That's because all those things are geared towards working in really resource constrained environments. So like your Tesla or your spaceship or something like that, mission critical, very low resource environments, versus what we are working with, like in web. You have almost infinite resources. Of course, in smart contract you don't. So even coming from web to smart contract is a shock, because like, oh, what, my extra 10 lines of code are going to cost $2 more. Yeah, let's bring that down.
Yeah. Yeah. So true. Yeah, no, yeah, of course I'm just kidding. I am slightly traumatized and have PTSD now, but it's fine. And to anyone out there that does immerse themselves in those kind of things, I completely admire you, and I think it's impressive, because I'm scared and I can't do it myself. Although I do try.
Yeah. What's interesting to me, and that I have dived into quite a bit, is around the cryptographic primitives like encryption, hashing, signing, etc. That I really enjoy getting into.
Yeah. So BC says, how do you set up a contract that is private so the algorithms functions are not publicly visible, but the functions inside the contract can be called by a smart contract in the Flow blockchain? Is this even possible? No, I don't think so.
Yeah, you would have to do it at a resource level. You need to be able to somehow hand off a resource to some other smart contract. And that's kind of what we are doing with the tenant.
Yeah. Yeah, I'm assuming that your use case here is something like where like you're not fully ready to deploy a contract, but you want to have the functionality there. And so you don't want to expose like the visibility of the contract, but still have it be functional. Yeah, yeah. So no, that's unfortunately it's not possible. I know that's a thing in Solidity, right? You were showing me the other day, but
Well, yeah, again, if you're talking about the code being visible, that's always a given. It's blockchain data, but the scope, so you can constrain the scope of it. So
yeah, like even in Solidity, these quote unquote like private contracts that you can't, like you can still see their code, right?
yeah, that
Yeah.
data always public. You cannot hide your code. You cannot hide your proprietary algorithm, etc. It's always available. You can scope it so it's not accessible, but that's authorization. Basically, that's authorization.
Yeah. What you could do, BZ, is maybe set up some sort of like temporary contract. Like, for example, if your contract is mainly utility based, meaning it uses another contract and just does some simple functionality and doesn't actually store any data in it, then I mean you could obviously just deploy that contract and use it and then deploy another contract at some later point. But oh, so the CryptoKitties gene algorithm is out there somewhere on ETH blockchain. Oh, so yeah, so you're referring back to again, I'm no ETH expert, but you're referring to the CryptoKitties gene algorithm
Yeah.
that
So
some other contract was using, right? But yeah.
yeah. So if memory serves me right, because I did do digging into that, I believe that they have the gene algorithm actually off chain. So when you mint a kitty, it submits so it was actually minted off chain and it submits into the transaction about what it should mint. Now that may have changed. It's been actually a couple of years since I last looked, but that's how TopShot also does it. And that's a familiar pattern. In fact, when we are creating some of these foundations for dAppStarter, we are assuming that you will have an admin role that has access to certain things and can do certain things where there's proprietary information that you submit. So that doesn't mean your app is not decentralized. It just means that certain proprietary algorithms, etc., you keep them off chain and you just do the calculations that are proprietary off chain and then submit the result to a transaction. Of course, it means that if you go away, then no one will be able to perhaps mint something new in your application. But then that might be okay, because if you are the creator of it and the minter of it and you don't want to do it anymore, then the smart contract and its data is still all good. You just can't mint new stuff.
Yeah, that honestly wouldn't that wouldn't surprise me. I think you're right, Nick, because on NBA Top Shot, like it's the same thing on NBA Top Shot where there's, like if you go on the website, there's packs and you can buy packs. But if you actually look at the smart contract code, there's no such thing as packs. It's all handled completely off chain, and they off chain will handle like the randomness of what moments will be in that pack, and then all they do is submit a transaction that takes those IDs that were just chosen off chain and just mints them into the account. So it's not completely bizarre that an application would just do that kind of thing off chain.
Yeah, I can probably let me pull up here a worksheet that I created for another sort of application that shows you how some of this might be created. So give me a moment here, and I will figure that out and show you. But it gives you a sense of how pack distributions and things like that are kind of handled. So give me a moment here.
Silver, we'll come to this in a second.
Yeah, so, all right, let me share my screen. So Jacob, I'm gonna knock you off here.
Oh, yeah.
So I'm gonna show you this worksheet here. So this is for an application that is trying to do a similar kind of thing as Top Shot. So when you are creating pack distributions, etc., what you have to do is essentially do these calculations and figure things out. So this is I just X'd out like kind of what's going on. The X's can be replaced with anything you want, you know. But these are this particular thing here essentially is what would be the equivalent of a pack. And what this is saying is that this is a pack that's going to have three whatever NFT, like in NBA Top Shot, it's called a moment, but you might call it, you know, a widget or a card or something like that, you know. And these here are calculations that affect the probability of, so your random generation engine, which will work off chain, can use this as a reference to produce the packs for the users, to essentially mint the packs. So it will use a random generation algorithm to go through these, and that's how the packs are minted. So like this one is any one, this would be a rare one, so it has, you know, different kinds. So essentially this is not rocket science. I mean, this is what anyone with a spreadsheet can sit and create. It takes a little bit of planning though, because you want to ensure that the distributions, etc., match and fit your sales goals, your sales targets, your revenue targets, and things like that. But if you intend to create a pack-based model, then you would need to create something like this off-chain to do that. If you're creating a genome-based module, NFT, then you would do something very similar. For example, the Fame Lady Squad, which was recently the subject of much controversy. Let me pull up and see if I can find their distribution worksheet, and it'll give you an idea of that. So give me one moment. I'll pull that up for you. Here we go. I found it right away because I was just looking at it the other day. Let's go share. But almost everybody who does an NFT drop, there's a lot of work that happens off-chain on figuring out the attributes, the distribution of those attributes, the rarity, etc. So this is the Fame Lady squad. If you've looked on OpenSea, let me go find my profile on OpenSea. So yeah, so there's the ladies, blah blah blah. So this is what we're looking at, and we can actually, this is on Ethereum, but it's fine. We can look, we're learning here. So you can see here it has background, clothes, eyes, face expression, head item, skin, etc. And so then if you come here, you can see that it's got those traits, you know. So someone in product management does this first before it even gets to a developer, etc. You have to figure out things like rarities, etc. And you can see here that calculation is all done here. So this is what drives the minting process. So when you have these worksheets, you can see that they've minted 8,888. And so for all of them, they're like, okay, which one should be rare? Clearly, like this one here is a very rare trait, ice. Like, let's look for others that are super rare traits.
And so all of this is handled off chain, right?
Yeah, this is all work you do in order to get to a drop. You do all that planning, etc. So then when you do the actual drop and you're minting, you basically have code that enumerates these percentages, these values, and based on that, it generates random numbers. So for example, when it's computing, there's two levels, right? The first level is the trait rarity. So A, should an earring manifest itself? and there's some randomness to that. If it says that, okay, 50% should have an earring, so then it uses that threshold to ensure that 50% have an earring. Once it's determined that, yes, this particular one I'm minting should have an earring, then it says, okay, now let's figure out the distribution and say, okay, so what should it be? So I'll give you a very trivial algorithm to come up with that, because it seems complex, but it can really be very, very simple. So let's say that you're faced with this here, here, and you have to figure out, okay, should I mint an emerald earring, a blue earring, or what? Well, guess what? You can easily just generate a random number from, for the sake of example, I'm going to keep it very small, but really you'd want to make it much larger. I'm going to say generate a random number from 0 to 100. Okay. And let's say that, actually, I'll make it 0 to 1000. All right. So if the number you came up with was, let's say, 200 or something like that, what you would do is you would basically add up all the percentages until you hit that value. And that's bucket is where what you would kind of use, whatever random number is. So I did a terrible job of explaining that. Let me try and explain again. If you think of these percentage values as really a collection of serial numbers of buckets, so you generate a random number and see which bucket that random number falls in, and that's the attribute you choose. So that's one algorithm to do it. There's many others, but that's really a very trivial algorithm to come up with that I frequently use when I do this kind of stuff. I don't know if that made any sense. Yeah.
So basically what's happening is like off chain. Oh, this is a question. So off chain, like, there's a 50% chance that the earring's blue, right? 50% chance that it's red, whatever. The glasses, there's a 25% chance it's orange. Yeah. All this stuff is happening off chain. And then once it decides what it is, then it will call into the contract, mint me a character with blue earrings, orange glasses, and blonde hair, right? And then it's already set in stone once it's calling into the contract. Yeah. Is that right? Yeah.
It's basically sort of, you can batch do this, or you can do it on the fly. So someone has requested and paid for an NFT, run the random algorithm, all of that, and generate and submit to chain. Now, this is where, in the Pact Foundation, we have with dAppCenter, et cetera, only the admin user can access that function to mint, because you don't want anyone to submit, oh, like, I think this is the rarest one, so here are the attributes, go mint
Give
it.
me LeBron.
Yeah, like, here we go, red, blue, laser, 0.67%. Let me just do that, Yeah, so you want to constrain about who can do that, but yeah, exactly how you describe it. The admin user, who is really the owner of the platform, who is responsible for minting it, right? So the reason that the organizations, or in this case, the group of dudes who minted this, publish this kind of stuff is for transparency. Like, you want to know, what are your odds of getting this kind of stuff, and to share it. It's harmless to share this information. It's not proprietary. All it tells people is, when you do get it, how rare is it? Like, and they use this kind of information to compute this. Like, see, 47% have this trait, etc. So you can either specify this or you can compute it. Either one works. So this particular one says that this has a pretty decent rarity kind of thing. So let's go and look at the same thing for my ape. So I have a fairly decent ape, but you can see that there's only 2 traits that are kind of rare. The others are more or less kind of common. But yeah, so
this awesome.
Yeah, this is the kind of thing, homework you have to do in order to build an application that is doing these drops and things like that. You have to do the math around it. And actually, I'm super glad this question came up, because we just talk about code. We don't talk about product. And this is all product decision making you have to do well before you get into the code. The smart contract is just a byproduct. It's like the end of having figured out all this. In fact, I would vouch that I would guess that if you're building sort of an NFT application, almost all your work is going to be in product and the user experience, like the look and feel of it, the actual NFT's appearance, etc. You look at NBA Top Shot as an example, like that is a lot of work to get that experience there. The contract, go look at it. It's not that complicated at all. It's very simple, you know?
Yep.
So while we are learning all this complicated cadence stuff and all that, just be aware that I would say upwards of 80% of your work is in product to create a killer application.
Yep. That's why this stuff is so interesting to me, because you'll see these NFT projects like Bored Ape or any of these genome projects, right? And it's like it looks so complicated. And then you look at the contract, and all it is a function takes in an eye color, a hair color, and whatever it may be, and boom, it's the moment. You're like, well, how's that happening? And the answer is, well, it's happening off chain in some algorithm that takes a lot of thought and effort beforehand. There's really a lot that goes into it.
Yeah, I guess I can also, like, if you're looking at sort of algorithms, it would be good to share that Mongram thing, and it's a good algorithm for people to look into how you could mint a genomic type of sequence and then store it off chain. And so this is actually available in dApps Charter. So this is the Dutch artist Mondrian. This is going to mint. Let's pick that color and generate. So there we go. So it just generated all these, which could be NFTs. But if you look at this sequence here, what this is this is all you really need to render this art up here. This is a sequence of essentially coordinate pairs. So it has the top left corner and the width and the height for every one of these. And then it base 64 encodes it. And now you have what looks like a genomic sequence. You store this in your NFT and you're done. You don't have to worry about storing PNGs or whatever. You just render it on demand anytime. So you can generate, whatever in different sizes, different quantities. These are not as fun, but yeah. But these are all just essentially genome kind of thing. So I wrote this for fun, and it is now available in dApps Charter.
Sweet. What a great discussion.
Hey Nick, so you showed us the Excel sheet, right? So the guys behind it, could they actually mint the rarest feature on their own? And like, because you said the Excel sheet, right, just for transparency, right? But they still have the ability to mint whatever they want.
Yeah, absolutely. You can mint whatever you want, and that's where you have to be able to essentially have a level of trust. Like right now, NBA Top Shot. How do you know what's in a pack, etc.? How do you know that? Well, you kind of have. It's a little bit of trust. Because they are minted off chain. Yeah. Okay. If you want to do all your minting on chain, then it requires you to have an oracle in order to get the random number, etc. And you can have that. I salute you if you're able to do that. But I have mentioned this several times now. I'll mention it again. We are in an era where the best apps, the ones that are most successful, are going to be hybrid Web 2, Web 3 apps right now. That's just because Web 3 is not fully baked yet to support complete decentralized apps. There's still tools and services evolving, and we are building some of them. So if you look at the big apps that are really, really successful, they don't even pretend to say we are fully Web 3. Ask an NBA Top Shot user, hey, what's your private key? They'll give you a blank stare. They have no idea because it doesn't exist. You don't even have access to your own assets there. You have a Dapper Labs account, and if you dig enough, maybe, in fact, but I'm not sure, you know that you can get your private key. I'm sure you will at some point. It's a custodial kind of service, but they focus more on the user experience. So I encourage everyone building today to have a sort of a hybrid experience, because that's what seems to work well. if you are building a financial app, then you don't have that luxury. You cannot do that. You can't have off-chain and on-chain. You got to do everything on-chain. But for NFTs, especially if you are the minter, etc., it's perfectly fine for you to control it because you are the originator of it. So, yeah.
But for example, the Bored Apes, right?
Mhm.
Aren't the final assets all on-chain?
Yes, the final assets are all on-chain. So that's where the drop comes in the picture, right? So they said, okay, we're going to do a drop. Here's all of them. They are minted and they're available. You can't see what it is, but you can buy it. And then at a certain time, we will reveal what that is. And so that's basically how that works. But now that the Bored Apes are done, there's no more being minted. So now it's just a market. Just trading is all that's going on. The minting part is done.
So the percentage rarity that you saw on OpenSea, right? That is not determined from some Excel sheet somewhere, right? It's all on chain.
It is now on chain. Yes, it is determined from reading the chain, but it was predicated but with a spreadsheet somewhere where at the time of minting.
Yeah.
Because otherwise, how are you going to mint? Like, you can't just send random data to the blockchain and it'll end up with some ape with 4 pairs of eyes and something, and that might be okay. That might be rare, but people want something that's cool, and they want to know that, yeah, this is the laser is rare or something like that.
So the interesting thing there is, if there is a corrupt developer who figures out, okay, this is the rarest trait, and they just try to mint everything, right? More of those, the on-chain numbers percentage would change, right? When someone's looking at OpenSea. Yeah.
Yep.
Okay. Even if they publish an incorrect Excel sheet, like 8,000 mints, right? Maybe they just
I would not heed or pay respect to the Excel sheet for the transparency part. But when those things are minted, it makes it easy for you to go and see that they are claiming that there's only one of these, but in fact there are 4 of them and 3 of them are sitting in the owner's account. Well, yeah, that's a problem. So then the value of that will not be, it'll reflect in the price on the marketplace.
Yeah.
I love having these kind of discussions, because then we are getting into the territory that is product centric. And while I love to talk about code any day, I feel like not enough developers think through the user experience, and that's why you end up potentially with low usage on there. But if you spend more time thinking about the user experience and having empathy for the end users, I think you can make better killer products if you with your skills of writing smart contracts. Yeah. All right. So I think we've gone an hour and 20, which is great. And we'll do the same thing tomorrow. I don't know what time it is scheduled for tomorrow.
Let me check right now. It might not even be scheduled.
Yeah, it's
No,
not scheduled.
It's not scheduled. Yeah.
We'll have to. I think we'll do that. We'll announce in the morning and schedule something.
Yeah.
I like this time, actually. It's a good time to chill and talk about it. So
yeah.
Great. Well, thank you, everyone. Loved your questions. Appreciate your involvement. And like I said, we want to continue the conversation moving forward and really help you build whatever it is you're building. And hopefully you will think of us as worthy partners, friends, buddies in your journey, and give us an opportunity to ride on that ride and with you, and see what we can build together. So thank you so much. Have a wonderful day, night, afternoon, evening, wherever you are.